So in my second video, I'm gonna start by discussing the progress of the alum in the vial, which was set on the room 3 weeks ago on Monday, January 23rd. And there's some crystals that are forming at the bottom already. It's been slowly evaporating, like the water in which the crystals was dissolved is slowly evaporating because of the cold temperature and the open window in the room, which brings in cold temperature. But as can be appreciated by these crystals, there's some what looks like bright dust, but if you look close enough, you can see some crystals. And then for the second part of the video, we're gonna discuss yield and how precise was this experiment. So basically, these are the formulas of the processes the alum went through since it was aluminum till it became alum. And so basically, as can be observed, there's a 1-to-1 ratio, which means that there's 1 mole of aluminum required per mole of alum that is produced. So to calculate the amount of the mass of the theoretical yield of alum, there's a couple steps that need to be taken. So first, it's important to keep in mind that there's 1 mole of alum per mole of alum. 1 mole of aluminum per mole of alum, and basically to calculate the moles of aluminum, you just divide the actual mass of the aluminum, which was taken in the lab with a scale, over the molar mass of the aluminum, and you get a total of 0.0376 moles. If you multiply that by the molar mass of the alum, you get 17.8 grams, which is the theoretical mass of the alum that should be achieved in this experiment. However, when the mass of the alum was taken before the experiment, it turned out to be 10.723 grams instead of the 17.8. So to calculate the percent yield, just divide that by the theoretical yield, multiply about 100%, and you get a total of 60.2% yield of aluminum. The reasons why it was not perfect might have been because of impurities in the aluminum. So basically, if we assumed that the aluminum foil we used for the experiment was 100% aluminum, but it might have not been true because of the processes it withtakes in the industry or in the company that manufactures it. So that needs to be taken into account. Also, it is important to keep in mind that we assumed that aluminum was the limiting reagent, but it might have not been. Depends on how much substance was added. So if there was a contaminated chemical, then that might have been the limiting reagent because it interfered with the amount that was added, that was supposed to be added, was not completely added. Or perhaps it was because of imprecise measurement of one of the many chemicals that was added to the experiment that caused the yield not to be 100%.